Welcome to AI Frontiers, where we explore revolutionary advances in artificial intelligence. Today, we're diving into computational linguistics breakthroughs that are reshaping how AI understands human language. We'll examine 38 cutting-edge research papers from July 30, 2025, discovering how machines are learning to handle ambiguity, process multimodal information, and build bridges between human communication and machine intelligence. These aren't incremental improvements. They're paradigm shifts happening right now. Picture this scenario. You're sitting in a doctor's office, and instead of waiting weeks for test results, an AI system instantly analyzes your symptoms, cross-references thousands of medical studies, and provides your physician with a comprehensive treatment plan tailored specifically to you. Or imagine filing a patent for your groundbreaking invention without hiring expensive lawyers, because an AI assistant can draft the complex legal documentation in minutes. What if a computer could assess your personality more accurately than a trained psychologist, simply by analyzing how you speak, move, and express yourself? These scenarios aren't science fiction anymore, they're today's computational linguistics reality. The revolution is happening in how machines understand human language, moving from simple pattern matching to sophisticated reasoning across multiple languages and cultures. Think of computational linguistics as the bridge between the messy, beautiful complexity of human language and the precise, logical world of computers. It's like teaching a brilliant but literal-minded alien to understand not just what we say, but what we mean, what we imply, and even what we deliberately leave unsaid. This field sits at the fascinating crossroads where linguistics meets computer science, where psychology intersects with mathematics, and where the ancient human art of communication encounters the cutting-edge science of artificial intelligence. For decades, this field has driven technologies we now take for granted. Every time you ask Siri for directions, use Google Translate, or rely on autocorrect, you're interacting with computational linguistic systems. But today's research pushes beyond basic understanding toward AI that can truly comprehend context, navigate ambiguity, and exhibit genuine reasoning. Imagine computational linguistics research as a vast ecosystem, much like a rainforest where different species occupy specialized niches while contributing to the overall health of the environment. In our research landscape, we can identify 6 distinct but interconnected themes that represent the most active areas of investigation today. Like a rainforest where each species contributes to ecosystem health, each research area builds upon and supports the others. From understanding how language models actually work to exploring human-AI interaction, from specialized applications in medicine and finance to architectural innovations that make systems more efficient, these themes create a rich, interconnected web of discovery. The interplay between these areas drives the field forward, with breakthroughs in one domain often catalyzing advances in others. The first theme centers on understanding and improving how large language models actually work. Think of these models as incredibly sophisticated but sometimes unpredictable students. Researchers are like teachers trying to figure out why these students sometimes give brilliant answers and other times make puzzling mistakes. Wu and colleagues discovered that even the most advanced models struggled terribly with ambiguous text, especially in Chinese, often displaying dangerous overconfidence when they should acknowledge uncertainty. This is particularly concerning because ambiguity is everywhere in human language. We navigate it effortlessly using context and world knowledge. Meanwhile, Lu's team found that while user feedback contains valuable learning signals, it's often too noisy to directly improve model performance. Like trying to learn from a classroom where everyone is shouting different suggestions at once. These findings reveal fundamental gaps in how current systems process and represent linguistic information. The second major theme explores multimodal understanding, where AI systems learn to process information from multiple sources simultaneously, much like how humans naturally combine what they see, hear, and read to understand the world. Sadana's research team created a benchmark that tests whether AI can understand cause and effect relationships by combining visual observations with written instructions. The results were sobering. Even the best models achieved only modest performance compared to humans, revealing significant gaps in how these systems integrate different types of information. This is like trying to learn to drive by only reading about it, without actually experiencing the relationship between steering wheel movements and vehicle direction. The research highlights specific failure modes where models excel at describing what they see but fail to understand how events and actions relate to each other across modalities. Current systems can describe individual elements but struggle to grasp the underlying causal relationships that connect them. Our third theme focuses on specialized applications, where general-purpose language models are adapted for specific professional domains. This is like taking a brilliant generalist and training them to become a specialist in law, medicine, or finance. Jaju's team developed Masca, a multi-agent system for credit assessment that demonstrates how AI can handle complex financial decisions while addressing crucial concerns about bias and fairness in lending practices. The system doesn't just automate existing processes, it provides transparent reasoning that financial institutions can audit and understand. Similarly, Eben's group created RASL, a framework for scaling text-to-SQL systems to enterprise-level databases, making vast corporate data repositories accessible through natural language queries. These applications show how domain-specific adaptation can create AI tools that are both powerful and responsible, addressing real-world needs while maintaining ethical standards. Among the most striking findings from this research wave is the fundamental fragility of language models when dealing with ambiguous text. Wu's systematic investigation revealed that state-of-the-art models cannot reliably distinguish between ambiguous and unambiguous content, often displaying dangerous overconfidence when interpreting unclear text as having a single, definitive meaning. This discovery is particularly significant because human language is inherently ambiguous. We navigate multiple possible meanings effortlessly using context, world knowledge, and pragmatic reasoning. The multimodal reasoning research shows dramatic performance gaps between humans and AI, with the best models achieving only 0.57 F1 score while humans achieve 0.98. User feedback analysis reveals that while feedback contains valuable signals, it's often too noisy for direct learning, with quality varying dramatically by task complexity. Positional bias research demonstrates that example placement in prompts can change accuracy by up to 6 points. Finally, structured representations consistently outperform natural language plans for complex reasoning tasks. Among all the fascinating research we've explored today, one paper stands out as particularly transformative. User feedback in human LLM dialogues. Learning from the Noise, by Liu and colleagues. This work tackles one of the most pressing questions facing the AI community today. How can we create systems that continuously improve from real-world interactions with users? The researchers embarked on this investigation with a deceptively simple question. When users provide feedback during conversations with large language models, can that feedback serve as a useful learning signal for improving the models? What makes this work particularly compelling is its focus on the messy reality of human-AI interaction. Unlike controlled laboratory settings where researchers carefully craft prompts and responses, real conversations between humans and AI systems are filled with ambiguity, frustration, misunderstandings, and unexpected turns. The team analyzed thousands of real conversations, developing sophisticated methods to categorize and analyze different types of feedback, revealing fundamental challenges in deployed AI systems. The research uncovered fascinating patterns about feedback quality that challenge common assumptions about human-AI interaction. One of the most surprising findings was that positive feedback, users saying, "good job," or "that's helpful," is often less informative for model improvement than constructive criticism. When users point out specific errors or suggest improvements, they provide actionable information that can guide model training. But generic praise doesn't tell the system what it did right or how to replicate that success in different contexts. The researchers also discovered that users who provide detailed, specific feedback tend to also write more comprehensive initial prompts, suggesting that the ability to give useful feedback is related to understanding how to interact effectively with AI systems. This creates a potential feedback loop where the users most capable of helping improve the system are also those who already know how to get good results from it. Perhaps most intriguingly, the study revealed that timing matters enormously. Immediate feedback tends to be more focused and actionable than delayed responses. The implications of this research extend far beyond academic interest, addressing fundamental questions about building AI systems that can adapt and improve throughout their deployment. As AI systems become more prevalent in customer service, education, healthcare, and other domains where continuous improvement is crucial, understanding how to learn from user interactions becomes both a competitive advantage and potentially a safety requirement. The work provides concrete guidance for companies developing AI products, suggesting specific strategies for collecting and utilizing user feedback while avoiding the pitfalls of noisy or misleading signals. The research also raises important ethical questions about consent and transparency. When users interact with AI systems, are they aware that their feedback might be used to train future versions? The authors thoughtfully address these concerns, suggesting frameworks for ethical feedback collection that respect user rights while enabling system improvement. The technical contributions include novel methods for automatically assessing feedback quality and identifying patterns that indicate when user input is likely to be helpful versus harmful for model training. Looking toward the future, this research opens exciting possibilities for AI systems that can adapt and improve throughout their deployment, rather than remaining static after initial training. Imagine educational AI that becomes better at explaining concepts based on student questions and confusion, or medical AI that refines its diagnostic suggestions based on physician feedback and patient outcomes. The potential for creating truly adaptive, continuously learning systems is enormous. However, the work also sounds important cautionary notes about the challenges of learning from human feedback. The researchers emphasize that human input, while valuable, is inherently subjective and context-dependent. Building systems that can effectively utilize this feedback while avoiding overfitting to individual preferences or biases requires careful design and ongoing vigilance. The research provides a roadmap for developing robust methods to distinguish helpful feedback from noise while ensuring that systems don't develop unwanted biases or behaviors through their learning processes. As we look toward the horizon of computational linguistics research, the work we've explored today points toward several exciting frontiers that could reshape how we interact with AI systems. Think of the future of this field as a garden where different research threads are growing and beginning to intertwine in unexpected ways. The discoveries about language model fragility are spurring development of uncertainty-aware architectures that can explicitly represent and reason about multiple possible interpretations, presenting users with alternatives when ambiguity exists. The gaps revealed in multimodal causal reasoning are driving research toward AI systems that can build and manipulate explicit causal models of the world, understanding underlying mechanisms rather than just describing observations. The insights about learning from user feedback point toward continuously adaptive AI systems that evolve based on interactions while maintaining safety and reliability. Architectural innovations are laying groundwork for more efficient models that can run on smaller devices while maintaining sophisticated reasoning capabilities. This democratization could enable applications we haven't yet imagined, from personal AI assistants to specialized tools in resource-constrained environments. The research we've explored today represents more than just academic progress. It's laying the foundation for AI systems that are more reliable, more useful, and more aligned with human values and needs. From careful analysis of language model limitations to development of new evaluation frameworks, from advances in multimodal understanding to insights about human-AI interaction, these discoveries are shaping a future where artificial intelligence truly serves as an extension of human intelligence rather than a replacement for it. The human stories behind this research are equally compelling. Teams of researchers around the world working to make AI systems more reliable, more useful, and more aligned with human needs. Their work represents not just technical achievements but a commitment to building technology that enhances rather than replaces human capabilities. What strikes me most is how this research balances ambition with humility, pushing boundaries while honestly acknowledging limitations, building more capable systems while making them more transparent and controllable. The future isn't something happening to us. We're shaping it together through curiosity, questions, and engagement with remarkable research. Thank you for joining us on AI Frontiers today. This research synthesis was created using Claude Sonnet 4 for analysis, with text-to-speech synthesis powered by Google systems and image generation capabilities provided by Google platforms. All content has been reviewed by human experts for accuracy, though some oversights may exist. We've provided all references for your verification. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses archived preprintserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archived preprintserver.org.